Hey everyone, welcome back to the channel. Today, we're diving straight into web scraping and data pre-processing, getting our data ready for a language model. We'll be using Pandas and Yahoo Finance to scrape the latest news on a stock of interest, clean it up, and prepare it for fine-tuning an LLM. Even though we are not directly working with stock data yet, there is one disclaimer I feel obligated to make before we get started, and that is, I am not a financial advisor. I am just a programmer, so please understand this video is meant to be educational and not intended to be taken as financial advice. So, with that out of the way, let's jump right in. Before we start coding, let's make sure we have our environment set up properly. I will be using Jupyter Notebook inside VS Code, since it makes it easier to run and explain the code step by step. First, source your virtual environment, then you need to install Jupyter Notebook and set it up in VS Code. To do that, run the command in your terminal, pip install IPI kernel Jupyter Notebook. It may take a bit to install, so I will fast forward a bit here. Next, make sure you have the Jupyter Notebook VS Code extension installed. Open the Extensions tab in VS Code. You can do this by clicking on the square icon on the left or pressing Ctrl plus Shift plus X and search for Jupyter. Install the extension and you're ready to go. Next, let's set up our notebook for the project. We'll create a new notebook file called scrape.ipnb under the notes directory of our project. This helps keep things organized and makes it easier to track our work. First off, let's take a quick look at the libraries we're going to use today. We have requests and Beautiful Soup for scraping the article text from web pages, Yahoo Fin for getting a list of news articles related to a specific stock, and Transformers for NLP pipelines like sentiment analysis and summarization. And of course, we'll use good old Pandas for managing our data. You can install all the libraries directly in the notebook by running !pip install Yahoo Fin, PyArrow, requests, HTML, LXML, HTML, clean, Beautiful Soup, for Transformers torch. Hugging Face's Transformers library is what we use for the NLP pipelines in our project. Specifically, we're using two pipelines here, sentiment analysis and summarization. Pipelines in Hugging Face are a high-level abstraction that allows you to perform various NLP tasks with pre-trained models easily, without worrying about the underlying implementation details. The sentiment analysis pipeline can help us understand the emotional tone of a given text. For example, it can tell us if an article about Microsoft is overall positive, negative, or neutral. In our project, we are using the Distilbert-based uncase fine-tuned SST2 English model, which is a distilled version of BERT, fine-tuned specifically for sentiment analysis tasks. We're also leveraging our GPU, device equals 0, to speed up processing. The summarization pipeline is used to generate concise summaries of each article. Instead of manually reading and summarizing every piece of text, this pipeline lets us quickly create a shortened version of the key information. This is particularly useful when we need to distill long articles into short, useful insights for training our LLM. Next, let's define the helper functions we'll be using throughout this notebook. These functions help streamline our workflow and make our code more reusable. The first function I'll write is the basic cleanup function. This function helps perform basic cleanup on the article text. Specifically, it normalizes Unicode characters to remove any special symbols that might cause issues, removes any unwanted special characters, and reduces extra spaces. This ensures that our text is clean and standardized before we perform further analysis. I also want to note that I will attach the link to the GitHub in the description, so you don't need to type out these regular expressions. You can grab them from the GitHub link instead. The next function is the summarize article function. This function takes in the article text and uses the summarizer pipeline from Hugging Face to generate a concise summary. We limit the input to 2056 characters. which is necessary since our model Mistral Nemo 12B has a maximum context window of 128,000 tokens, then generate a summary of manageable length. This helps in extracting the key points of long articles effectively. Now let's create the add sentiment function. This function takes our data frame and adds a sentiment score for each article. It uses the sentiment pipeline to analyze the emotional tone of each article, returning either positive, negative, or neutral sentiment labels. If the article text is not available, which you will see that we will later mark those articles as NA, we assign a sentiment of unknown. You will see why in a bit here. I am getting an error here saying PD is not defined. No worries, I just need to rerun all cells to re-import the library, and we should be okay. This function is responsible for scraping the text from a given URL. It makes an HTTP request to fetch the web page, extracts all paragraph elements using beautiful soup, and then combines them into a single text string. We also apply the basic cleanup function to clean up the text before returning it. If the request fails for any reason, such as a non-200 response code or a timeout, the function handles the error gracefully and returns NA. These helper functions are key to making our code modular and readable, allowing us to easily clean, summarize, and analyze the data we fetch. Now we are ready to get our data. We'll be using the Yahoo Finance library to fetch recent news about a particular stock. The library allows you to pass a ticker symbol, and then it will fetch the latest news on Yahoo Finance's website pertaining to that symbol. I will use MSFT, also known as Microsoft, in this video. We then load the returned data into a Pandas data frame for further processing. Let's take a look at how this outputs. Next, let's pre-process the data we fetched. This step is crucial for our training data to turn out nice, and we are also going to start making use of our helper functions here. The pre-process data function takes in a data frame of articles and prepares the data for later use. First, we select only the relevant columns, summary, link, published, and title, from the original data frame, helping us focus on the most essential pieces of information for our analysis. Then, we use a thread pool executor to fetch the content of each article in parallel by calling the getArticleText function for each link in the data frame. This approach is much more efficient compared to fetching each article sequentially, as it saves us time. Once the articles are fetched, we add them to a new column called article text in the data frame. After that, we apply sentiment analysis to each article using the add sentiment function. This step allows us to enrich our dataset with a sentiment label, positive, negative, or neutral, that helps provide more context for our LLM. Finally, the cleaned and enriched data frame is returned, containing all the necessary information, article text and sentiment, that we need for further processing and training our language model. This pre-processing step is critical to ensure our data is in the right format and contains all the valuable information we need before we move to the fine-tuning stage. Let's look at the output of the pre-processing step to see how our dataset looks after this transformation. The last step is to prepare the data for fine-tuning our language model. For this, we will create the Prepare Fine-Tuning Data function, which takes in the cleaned data frame and transforms it into a format suitable for training a language model. In this function, we iterate through each row of the data frame and build a training example for every article that has a valid sentiment label, i.e., not unknown. We construct a context string that includes the title of the article, the published date, the cleaned up article text, and the sentiment label. This context gives the language model a comprehensive understanding of the article's content and its sentiment. We then pose a question. What is the sentiment of this article and why? This prompt helps guide the language model to understand the purpose of the training data. To provide an answer, we use the Summarize Article function to generate a concise summary of the article. The sentiment label and summary are then combined to form a complete response, providing the rationale behind the sentiment. These prompt response pairs are appended to a list called training data. Finally, we save the list of training examples to a JSON-L file that I will call olamatrainingdata.jsonl, which will serve as the dataset for fine-tuning the language model. JSON-L format, JSON lines, is commonly used for training data as it allows each example to be stored in a separate line, making it easy to parse during training. The purpose of this step is to provide our language model with structured examples of financial news articles, along with their sentiment and reasons behind it. This way, the model can give us a concise breakdown of how a given stock is being portrayed in recent news. And there we have it. We've gone from setting up our environment to fetching news articles, scraping, cleaning, processing, and finally structuring the data for an LLM to learn from. The data we processed today turned out to have a negative bias, indicating that Yahoo News on MSFT has a negative outlook on Microsoft stock right now. In the next video, we'll look at how to actually use this preprocessed data to fine-tune our LLM, and then we'll test the model with this specific data before generalizing it to any ticker symbol. Thanks for watching. Don't forget to like, subscribe, and leave a comment below if you have any questions or ideas for future videos. See you next time.